Let's discuss the relationship between Ka and Kb. There is a mathematical equation that relates to both of them, and that is as follows. It is that Ka times the Kb is equal to Kw. Kw represents the equilibrium constant of water, whereas Ka represents the equilibrium constant for an acid. And Kb represents the equilibrium constant for a base. And I like to put in the value of Kw at this point, which is 1.0 times 10 to the negative 14. And we may have seen this, that the hydronium concentration and hydroxide concentration multiplied together is equal to the Kw, which is 1.0 times 10 to the negative 14. So if you were to kind of put all of this together, we can say that the product of the acid dissociation constant for an acid and the base dissociation constant for this base right here, for its conjugate base, equals to the ion product of water. That's another fancy way of saying what Ka and Kb relates to. Really, it's saying Ka times Kb is equal to Kw. Let's do a learning check based on what we have seen so far. Nitric ion, or NO2- has a Kb of 2.17 times 10 to the negative 11. What is the Ka for its conjugate acid? So we know that we have Kb, but we don't have Ka. So we can set this up in which Ka times Kb is equal to Kw. We know the value of Kw as well. So if I want the Ka by itself, we're going to divide Kb both sides, canceling the Kb, so we have just Ka equals the Kw and denominator Kb. Kw is 1.0 times 10 to the negative 14. Kv value is 2.17 times 10 to the negative 11. And that will give me Ka. It's important that you're careful with the parentheses here so that you're not miscalculating. So parentheses 1.0 times the 10 to the negative 14. And then I'm going to close that parentheses, divide that by, open up another parentheses, 2.17 times 10 to the negative 11. And then close that parentheses and hit enter. Then you get 4.6 times 10 to the negative 4. This is my Ka value. Can you guess if this particular nitric ion is a weak acid or a strong acid? Well, you can tell by the Ka value being less than 1, this is a weak acid.